Hello and welcome to the next in our series of hardest questions at GCSE. This one dates from 2018, paper 3 higher. We've got a parallelogram. ABCD is a parallelogram as shown in the diagram. ABP and QDC are straight lines. We could also see that they are parallel because we have the notation there here and here, so those two line segments are parallel, and angle ADP is equal to angle CBQ, and they're both 90 degrees, and we can see those marked on the diagram. Part A, prove that triangle ADP is congruent to triangle CBQ. So congruency means that two or more shapes are exactly the same shape and exactly the same size. So in other words, identical. So how can we do that with a triangle? We have a couple of options. We have side, side, side congruency. So that would be SSS. We also have side, angle, side congruency. We have angle, side, angle congruency. And we have RHS as well, which is right angle, hypotenuse, and one other side. Let's have a look at which of those methods we could use here. So ADP is this triangle here, ADP. Let's draw in a different color the triangle CBQ. So CBQ. Okay, so we know we've got both of those triangles share right angles. So we've got that aspect. So we've got a common angle. We've also got, if you look carefully at ABCD, the parallelogram, opposite sides in a parallelogram are equal, and we can see that we have a pair of opposite sides which actually go to make up the two opposite sides in the parallelogram, but they're also on one triangle and on the other. So we've got a matching pair of angles, we've got a matching pair of sides because they're opposite sides in a parallelogram. So we just need one other factor there to prove that those two triangles are congruent. So what could we go for? Let's have a look at the angle here and the angle here. Well, they are two opposite angles in a parallelogram, and they are equal. So we have effectively, let's do this in black. So we have an angle, matching angles, right angles. We have two matching side lengths. So we have angle, side, and the yellow marked angles are opposite and equal. So we have angle, side, angle in both of those triangles. So let's just write those reasons down and gain all 3 marks for this part of the question. So we're going to use ASA congruency. As our kind of principle to prove. So first of all, 90-degree angles. So we have angle ADP equals angle CBQ. So two same angles. Okay. We then have two matching sides. So we have BC, length BC equals length AD. And the reason there is that they are opposite sides in a parallelogram. Opposite sides in a parallelogram are equal. There's your full reasoning. And finally, we have the two opposite angles in that parallelogram. So therefore, angle BAD is equal to angle BCQ. And the reason there is that opposite angles in a parallelogram are equal. So we have A, S, A. Therefore, triangles ADP and CBQ are congruent. Part B, explain why AQ is parallel to PC. Okay, AQ. Let's do this in a different color. Let's do this in. Let's go for purple. AQ is the length here. Okay, so that's this length here, and we've got to prove that explain why that is parallel to PC here. Okay. Well, we've already ascertained that, let's write this in black. So we've already figured out that AP is equal to QC. We've got that from the proving of the two triangles being congruent. So therefore we have AP equals QC in length, right? And are parallel, okay, as indicated on the diagram. Therefore, AQ equals PC because APCQ is a parallelogram. Yeah, so this side here, the top side and the bottom side are parallel. They're equal in length. So these two sides must constitute with the other two a parallelogram. So I think I've just gone off the bottom of the screen there. So AQ equals PC. Let's just put this AQ equals PC because APCQ is a parallelogram. Just squeeze this in here, I think. So that means, so I'm just going to go up here. So that means, therefore, that AQ is parallel to PC. And that's the end of that question. Thank you very much.